In this lesson, we're going to be graphing cotangent functions. Our approach is going to be the same as it was in graphing tangent functions. The only difference is going to be what we set bx minus c equal to. So as a reminder, these were our parent functions for tangent and cotangent. When we were graphing tangent functions, remember we set bx minus c equal to negative pi over 2 and positive pi over 2. Well, we're now graphing cotangent functions, so we're going to be setting bx minus c equal to 0 and bx minus c equal to pi. And everything else should be the same. All right, so for our first example, we're going to state a through d. And we're going to kind of think about, as we write these down, what effect on the graph each of these values will have. So 2/3 is going to vertically shrink our graph. There'll be no period change because b is 1 and c is 0 and d is 0. So no horizontal shift left or right and no vertical shift up or down. All right, to get started, let's take bx minus c, which that's just going to be x, and we'll set x equal to 0 and x equal to pi. So for tangent, we set equal to negative pi over 2 and positive pi over 2, but remember, take a look, we're graphing cotangent, so we want to set bx minus c equal to 0 and pi. Well, we don't have to solve these, we're done. There's no change to the vertical asymptotes. So I'll just come over here and plot those. You decide how many tick marks you want to go from x equals 0 to pi. I'll just do 4. Dash in. And I'll dash on the y-axis. All right, so there's no shift up or down. We do have a vertical shrink. So halfway between these two consecutive vertical asymptotes, we will have a x-intercept. And remember, cotangent starts from up here and completes itself going downward. A shrink would be where the graph is a little bit wider, so it approaches these vertical asymptotes a little more quickly. All right, then we're going to go ahead and fill in all the requested information. Remember, for the cotangent graph and tangent graph with vertical asymptotes, the period begins right after x equals 0 and it ends right before x equals pi. Subtract these two, the period is pi, or pi divided by b, which is just 1. Right, so the equation of the vertical asymptotes for the requested information in E is x equals, I'm going to start at 0, 0 plus, I'm not even going to write 0 though, and it's always n times the period. All right, for example 8, for this cotangent graph, A is 1, all right, B, remember x over 4 can be thought of as 1/4 x, so B is 1/4. So that's going to affect our vertical asymptotes. It's actually going to stretch them out a little bit, horizontally stretch. We don't have a C value because we're not adding or subtracting. I don't see a parentheses, and we don't have a shift up or down. So let's take x over 4, or if you want to write it as 1/4 x, that's fine. Take 1/4 x and set it equal to 0 and pi. All right, let's multiply both sides by 4 to get x by itself. Well, that's still going to be 0. Multiply both sides by 4, so x equals 4 pi. All right. And sketching those vertical asymptotes. I think I'll let 2 tick marks be 1 pi, so maybe that'll work. Let's see, that'll be 1 pi, 2 pi, 3 pi, yeah, there'll be enough room. So that's a pi, 2 pi, 3 pi, and then 4 pi. Dash in. Go back and adjust for any A and D values. We already took care of B and C through the vertical asymptote, so no changes to the graph, vertical stretch or shrink or vertical shift up or down. So halfway between 0 and 4 pi, which is 2 pi, I'm going to have that x-intercept, and of course cotangent comes down this way and then bends back this way. And the period's going to be the difference of these two, so that's 4 pi. Or remember, we would take pi for cotangent and tangent and divide by b, and our b was 1/4, but that would give us 4 pi. Just kind of a built-in check process. So all reals except x equals, my first vertical asymptote is at 0, so 0 plus n times pi, so that would be n times, or excuse me, that'd be n times the period, and the period is 4 pi. Usually we write it as 4 and then an n and then a pi. So always an integer multiple n times the period for cotangent and tangent. So domain is going to be all real numbers except those vertical asymptotes, which makes sense. Our vertical asymptotes occur in increments of 4 pi. Okay, A is -1, so we're going to reflect cotangent, so that's going to make it look like a tangent graph. B is 3, and we have 2 zeros here. All right, let's take B, x minus c, or just 3x in this case. Set it equal to 0, and set it equal to pi. I'm not going to multiply by 1/3, might as well just divide by 3, because there's no fractions over here. So x equals 0, and x equals pi over 3. So our period is quite diminished from pi down to 1/3 of a pi, but we can choose as many tick marks as we want over here to represent this distance. So 1, 2, 3. I might just choose a tick mark or 3 tick marks to be pi over 3. Or you can do 4, whatever you want to do. I'll just put pi over 3 there. All right, I need to adjust for the A value so that instead of coming from above and going below, halfway in between these 3 tick marks at about 1.5, I'll reflect the tangent graph so that it looks like or reflect the cotangent graph so it looks like the tangent graph. And then we'll fill in the information. Subtract these two, that's going to be your period, or again, remember it's pi divided by b. So all reals except x equals, you can put a 0 here if it makes you feel better, plus n times the period. So n times pi over 3. So every 1/3 of a pi will have another vertical asymptote. And I'll just put n pi over 3 here. All right, we'll continue graphing more cotangent functions with transformations. It looks like we're building a little bit with these last 3 examples to more complicated cotangent functions. All right, 10. A is 1, B is 1. Because B is 1, I don't have to factor any B value out, so my C value is the opposite, so it's going to be negative pi over 2. And D is 0. All right, our left vertical asymptote is at x plus 2, excuse me, x plus pi over 2 equals 0. And then over here, oh my goodness, x plus pi over 2 equals pi. So always 0 and always pi for cotangent. Subtract a pi over 2, so x is negative pi over 2. Subtract a pi over 2 from a whole pi, and that's just pi over 2 again. This is looking like the tangent graph. So this is our left vertical asymptote and our right vertical asymptote. Sometimes you'll see LVA for left vertical asymptote and RVA for right vertical asymptote. I gotta go left and right the same amount, so I don't know, we'll make 2 tick marks, get us to negative pi over 2 and to positive pi over 2. All right, so these are our vertical asymptotes. So we're taking the cotangent graph and shifting it left pi over 2, so it's gonna really look like the tangent, at least with the vertical asymptotes, but there is no reflection, so halfway between I've got my x-intercept, and it's still a cotangent graph without a reflection, so it'll look like this. And we know that total distance between those consecutive vertical asymptotes will be pi, or pi divided by b. All reals except x equal, or not all reals except, that's the domain. X equals, I will choose pi over 2, and I'm going to add n times the period. So in this case, since we shifted cotangent to the left, we have the same equations for the vertical asymptotes for this cotangent graph that we do for the tangent graph. We're good there. 11 and 12. So this is a vertical shrink, so the graph won't be as steep, it'll be more flat. B is 1, and C is positive pi over 4, with no vertical shift up or down. All right, let's give the equation for the left vertical asymptote. So it's bx minus c equals 0, and then also equal to pi. And 0 and pi, because those are cotangents periods that we work off of. So add a pi over 4. And let's add a pi over 4, a fourth of a pi to pi. So that'll give us 5 pi over 4. And I will just count one, each tick mark is a pi over 4. So 1 pi over 4. 2, 3, 4, 5 pi over 4 right here. Because we're shifting cotangent right pi over 4. All right. I don't have a vertical shift up or down, so I will have an x-intercept, a nice one. I mean, I would anyway, even if I shifted it up or down, but I can count the distance between these asymptotes as 1, 2, 3, 4. Half of that is 2, so right here is where we're going to have an x-intercept. I'm not reflecting cotangent, there's no negative, but I am shrinking it, so it gets a little bit flatter. The difference here is 4 pi over 4 or just pi. Yep, pi over b is 1. I will choose pi over 4 and then add an integer multiple of the period. So if I start at pi over 4, the next vertical asymptote is going to be a pi over, which is correct. We do have a reflection and a vertical stretch. B is 1. Okay, now be careful. See this x minus 3? It is not in parentheses. Had there been parentheses around x minus 3, then 3 would have been our c value. But just think of this as being x right there. So c is 0, And actually that minus 3 is your d value. So d is -3. So we're going to take bx minus c, which is just x, and set that equal to 0, and set x equal to pi. Oh, well, it looks like the period didn't really change. All right, x equals 0, pi, I might just count 4 tick marks, oops, to be pi. All right, we've got cotangent, but it's been reflected, and it's been shifted down 3. So reflection, vertical stretch by 2, it's thinner, and then move down 3. So halfway between here would be 2 tick marks over. I'm not going to put a point here. I've got to shift this point down 3. So 1, 2, 3. So the x-intercept that would normally be here is moved down here. Cotangent needs to be reflected. So instead of starting from above, I'm actually going to start from below. And I'm going to try and stretch it and make it thinner, more narrow. Something like that. So let's clearly show that point right there, what we call a point of inflection, where the bend kind of changes. We call that a change in concavity. Range is always the same. Easy, that's pi. Pi divided by 1. X equals, I have a vertical asymptote at 0, so 0 plus n pi, or you can just do n pi. And that's it on graphing cotangent.